Hello everybody, I am Dr. Jeetendra Pande and I am working as an assistant professor in Department of Computer Science at Uttarakhand Open University, Haldwani, and I am your instructor for this module. Today we will discuss history of internet. And after studying this module, you should be able to understand the history and evolution of internet, know the advantages of packet switching networks, explain the reason why ARPANET was designed, define the role of internet browsers, explain internet addresses, know the functions of DNS, understand internet infrastructure, and understand World Wide Web. The internet has grown so rapidly and become indispensable so quickly that it can be hard to remember that it is still a fairly new medium. Most people use the internet daily for personal and increasingly for business purposes. Children are growing up with online activities as a second nature. Even in rural and lower income communities, opportunities for internet uses are spreading. Individuals go to the internet for information, employment, education, entertainment, relationships, and support. It has facilitated our life in more than one way. Have you ever wondered from where the internet came? Let us discuss the brief history of internet and learn how this internet was invented and how it evolved to an extent that now we cannot think of our lives without it. So we will start our discussion with the historical perspective of the internet. I don't know what the Cold War between USA and Russia gave to the world, but definitely the internet is one of those very useful inventions whose foundation was laid during Cold War days. Russia launched the world's first satellite Sputnik into the space on 4th of October 1957. This was clearly the victory of Russia over the cyberspace, and as a counter step, ARPA or Advanced Research Projects Agency, the research arm of Department of Defense, United States, declared the launch of ARPANET or Advanced Research Project Agency Network in early 1960s. This was an experimental network and was designed to keep the computers connected to this network to communicate with each other even if any of the node due to the bomb attack fails to respond. The first message was sent over the ARPANET, a packet switching network, by Leonard Kleinrock Laboratory at University of California, Los Angeles. You will be surprised to know that the first message that was sent over internet was letter LO. Actually, they intended to send word login, but only the first two letters reached its destination at second network node at Stanford Research Institute, and before the last three letters could reach the destination, the network was down due to glitch. Soon, the error was fixed and the message was resent. The major task that ARPANET have to play is to develop rules for communication, that is, protocols for communicating over ARPANET. The ARPANET in particular led to the development of protocols for internetworking in which multiple separate networks could be joined into a network of networks. It resulted in the development of TCP/IP protocol suite, which specifies the rules for joining and communicating over ARPANET. Soon after, in 1986, NSF or National Science Foundation backbone was created and 5 US universities computing centers were connected to form NSFNet. The participating universities were Princeton University, Cornell University, University of Illinois, Carnegie Mellon University, and General Atomics San Diego Supercomputer Center. NFSNet, the successor of ARPANET, became popular by 1990s and ARPANET was decommissioned. In 1965, Donald Davis and his colleagues at the UK National Physical Laboratory independently discovered the idea of packet switching and later created a small-scale packet switching version of ARPANET. Michigan Educational Research Information Triad formed Merit Networks in 1966, which was funded and supported by State of Michigan and the National Science Foundation. France also developed a packet switching network known as Cyclades in 1973. Now there were many parallel systems working on different protocols, and the scientists were looking for some common standards so that networks could be interconnected. In 1978, TCP/IP protocols were ready, and by 1983, the TCP/IP protocol were adopted by ARPANET. In 1981, the integration of two large networks took place. NFS developed Computer Science Network, which is known as CSNet, and was connected to ARPANET using TCP/IP protocol suite. Now the network was not only popular among the research community, but the private players also took interest in the network. NFS supported a speed of 56 kilobytes per second. It was upgraded to 1.5 megabits per second in 1988 to facilitate the growth of network by involving Merit Network, IBM, MCA, and State of Michigan. After the corporates realized the strength and merit of this network, they participated in the development of the network to reap its benefits. By late 1980s, many internet service providers emerged to provide the backbone for carrying the network traffic. By 1991, NFS net was expanded and was upgraded to 45 megabits per second. Many commercial ISPs provided backbone service and was popular among the corporates. On 30th April 1995, the NSF net backbone service has been successfully ported to a new architecture, and the NSF net backbone was decommissioned. Now the internet could carry commercial traffic. Now more and more universities and research centers throughout the world were connected to it. This network was very popular among the research community, and in 1991, National Research and Education Network, known as NREN, was founded and the World Wide Web was released. Initially, the role of internet was only limited to file transfer. The credit of internet, what we see today, goes to Tim Berners-Lee, who introduced World Wide Web. With the advent of www, there was a transformation on how the network was used. Now this web of information can be used to retrieve any information available over the internet. Software called browser was developed to browse the internet. It was developed by researchers at University of Illinois in 1992 and named as Mosaic. These browsers enable to browse the internet the way we browse it today. With so many devices connected to the internet, we require some mechanism to uniquely identify every device that is connected to the internet. For sending a data packet from source computer to destination computer on a network, it is required that both nodes have their own unique address. We also require some centralized system which take care of this mechanism so that the signs which are used to identify each device are not duplicate, else the whole purpose is defeated. To take care of this, we have a centralized authority known as Internet Assigned Numbers Authority, which is responsible for assigning a unique number known as IP or Internet Protocol Address. An IP address is a 32-bit binary number which is divided into 4 octets, and each octet consists of 8 binary digits, and these octets are separated by a dot. Each 8 bits in the octet can have 2 binary values, that is 0 and 1. Therefore, each octet can have minimum value of 0, that is 8 zeros, to maximum value 256, that is all ones. And in total, we have 2 raised to power 8, that is 256 different combinations. Again, to remember this 32-bit addresses in binary is a bit difficult. So for better understanding of a human being, it is expressed in a decimal format. But this decimal format is for human understanding only, and the computer understands it in binary format. In decimal, the above IP address is expressed as 123.45.78.125. These octets are used to create and separate different classes. An IP address consists of 2 parts, that is network and host. Network part identifies a particular network among different networks, and the host part identifies a device of a particular network. This address uniquely identifies a devices connected to the internet, similar to the postal system where we identify any house by first identifying the country, then state, followed by district, post office, cluster or block, and finally the house number. The system of IP address classes was developed for the purpose of Internet IP addresses assignment. The classes created were based on the network size. For example, for a small number of networks with a very large number of hosts, the class A was created. The class C was created for the numerous networks with the small number of hosts. These IP addresses are classified into 5 categories based on the availability of IP range. These categories are class A, B, C, D, and E. Each class has a range of valid IP addresses. The value of the first octet determines the class. IP addresses from the first 3 classes, that is A, B, and C, can be used for host addresses. The other 2 classes are used for other purposes, that is class D for multicast and class E for experimental purposes. In class A IP addresses, the network ID is 8-bit long and the host ID is 24 bits long. It has 128 network IDs and approximately 16 million host IDs. IP addresses belonging to class A ranges from 0.0.0.0 to 127.0.0.0. In class B IP addresses, the network ID is 16-bit long and the host ID is 16-bit long. It has 16,384 network addresses and 65,534 host addresses. IP addresses belonging to class B ranges from 128.0.0.0 to 191.255.0.0. In class C IP addresses, the network ID is 24 bits long and the host ID is 8 bits long. It has approximate 2 million network addresses and 254 host addresses. IP addresses belonging to class C ranges from 192.0.0.0 to 223.255.255.0. IP addresses belonging to class D ranges from 224.0.0.0 to 239.255.255.255, and IP addresses of class E ranges from 240.0.0.0 to 255.255.255.255. IANA decentralized the task of assigning the IP addresses by allocating the large chunk of IP addresses to 5 regional internet registries, which are further responsible to allocate the IP addresses in their zone. These RIRs are APNIC, AFRIC-NIC, ARIN, LAC-NIC, and RIPE-NCC. APNIC is responsible for serving the Asia-Pacific region. AFRIC-NIC is responsible for serving the African region. ARIN is responsible for serving North America and several Caribbean and North Atlantic islands. LAC-NIC is responsible for serving Latin America, Caribbean, and RIPE-NCC is responsible for serving Europe, Middle East, and parts of Central Asia. For liaising and coordination between these 5 RIRs, there is an organization called Number Resource Organization, or NRO. Whenever we browse any website in the internet, we type name something like www.uou.ac.in. We rarely deal with IP addresses like 104.28.2.90, but the fact is, even if we type the IP address in the URL, it will land us to the same web page. The fact is, we are very comfortable using and remembering the names instead of numbers. Moreover, these IP addresses changes over time, and some of these sites have multiple IP addresses. Also, the transfer of data over internet is only possible using IP addresses because the routing of the packet of data sent over internet is done using IP address. There is a server called Domain Name System, or DNS, which takes care of this translation job to simplify and to save us from remembering these changing IP address numbers. Whenever you type an address like www.uou.ac.in, there is a process called DNS name resolution takes place in the background. The computer keeps the track of recently visited sites and locally maintains a database in DNS cache. In case the IP address of the site you have requested for is not found in the DNS cache of your local computer, then the next probable place to find it is DNS server of your Internet Service Provider or ISP. These DNS servers of ISP also maintains the cache of the recently visited pages. Just in case the information is not found here also, the DNS server of the ISP forward the query to the root name servers. The root name servers publish the root zone file to other DNS servers and clients on the internet. The root zone file describes where the authoritative servers of the DNS top level domain or TLD are located. There are currently 13 root name servers which are listed here. These root name servers directs the query to the appropriate top level domain name servers by reading the last part of the URL first. In our example, the URL was www.uou.ac.in. The last part is N. Some of the example of TLD name servers are .com, .biz, .org, .us, .in, etc. These TLD name servers act as a switchboard and direct the query to the appropriate authoritative name server maintained by each domain. Authoritative name server maintains DNS record along with other useful information. This address record is returned back to the requesting host computer via name server ISP DNS server. Intermediary servers keep the record of this IP address in their DNS cache so that if the same request is encountered again, they don't have to go through this process again. If the same URL is requested again, the DNS cache of the local host computer will return the IP address of the URL. Internet, as the name suggests, is a network of networks. That is, it is a collection of several small, medium, and large networks. This clearly indicates to one fact: nobody is a single owner of the internet, and it is one of the proven example of collaborative success. Now you must be surprised how such a large network, which is spread across the continents, can run without any problem. Yes, it is correct that to monitor such a large network, we require an international body which can frame the rules, regulations, and protocols to join and use this network. Therefore, an international organization known as the Internet Society was formed in 1992 to take care of such issues. Let us now discuss how this internet works. How the email you send to your friend is received by your friend's computer located at another country or continent. When you are working in your computer in your home without connecting to the internet, your computer is a standalone system. But whenever you connect to the internet by dialing to your internet service provider using your modem, you become a part of the network. The ISP is the link between the internet backbone through which the entire data route and the user. The ISP connects to the internet backbone at network access points or NAP. These NAPs are provided by the large telecommunication companies at various regions. These large telecommunication companies connect the countries and the continents by building and maintaining the large backbone infrastructure to route data from NAP to NAP. ISPs are connected to this backbone at NAP and are responsible to build and manage network locally. So when you dial internet through modem, you first become a part of the local ISP, which in turn connect to the internet backbone through NAP. The data is routed through this backbone and sent to the destination NAP, where the ISP of your friend's network is located. As soon as your friend dials his modem to connect to the internet, the data is delivered to your friend's computer. Sometimes we interchangeably use the term internet and World Wide Web, or simply the web, as it is popularly known as. But web is only one of the several utilities that internet provides. Some of the popular service that internet provides other than web is email, Usenet, messaging service, FTP, etc. The web use HTTP protocol to communicate over internet and to exchange information. The web was developed at CERN by a UK scientist Tim Berners-Lee in 1989. It consists of all the public websites and all the devices that access the web content. WWW is an information sharing model which is developed to exchange information over the internet. There are plenty of public websites, which is a collection of web pages available over the internet. These web pages contain plenty of information in the form of text, video, audio, and picture format. These web pages are accessed using an application software called a web browser. Some of the examples of popular web browsers are Internet Explorer, Chrome, Safari, Firefox, etc. Now we will discuss about Internet in details. The Internet stands for interconnection of computer networks. It is a massive heterogeneous combination of millions of computers, network devices, smartphone devices, all connected by wires and wireless signals. There are different definitions of Internet, but the meaning is the same. Some of the popular definitions are: the first definition is the series of interconnected network allowing communication of data surrounded by millions of computers worldwide. The second definition is a global communication network that allows computers worldwide to connect and exchange information. And the third definition is a worldwide system of computer network, a network of networks in which users at any one computer can get information from any other computer. Although it started in 1960s as a military experiment in communication, the Internet evolved into a public free broadcast forum in the 70s and 80s. No single authority owns or controls the Internet, although there are companies that help out to manage different parts of the network that ties everything together. We use the term Internet and World Wide Web interchangeably, but they are different. Let us now discuss how is the Internet different from World Wide Web. In 1989, a large subset of the Internet was launched as a World Wide Web. The web is a massive collection of HTML pages that transmits through the Internet's hardware. You will hear expression Web 1.0, Web 2.0, and the invisible web to describe these billions of web pages. The web is one software application or service that runs on the Internet. It is a collection of documents and resources in the form of web pages. It provides easy access to a huge range of information that is stored on computers around the world. The expressions web and Internet are used interchangeably by a layperson. This is technically incorrect as the web is contained by the Internet. Now let us quickly discuss what is Web 1.0, Web 2.0 and the invisible web. We will start with Web 1.0. When the World Wide Web was launched in 1989 by Tim Berners-Lee, it was comprised of just text and simple graphics as a collection of electronic brochures. The web was organized as a simple broadcast receive format. We call this simple static format as Web 1.0. Today, millions of web pages are still quite static, and the term Web 1.0 still applies. In the late 1990s, the web started to go beyond static contents and began offering interactive services. Instead of just web pages as brochures, the web began to offer online software where people could perform tasks and receive consumer-type services. Online banking, video gaming, dating services, stock tracking, financial planning, graphic editing, webmail services like Gmail, Yahoo, etc. All of these become regular online web offerings around year 2000. These online services are now referred to as Web 2.0. Names like Facebook, Flickr, eBay, and Gmail help to make Web 2.0 a part of our daily lives. The invisible web is the third part of the World Wide Web. Technically a subset of Web 2.0, the invisible web describes those billions of web pages that are purposely hidden from regular search engines. These invisible web pages are private, confidential pages and web pages generated by specialized databases. Invisible web pages are either hidden completely from your casual eyes or require special search engines to locate. Now let us discuss what is a website. Website contains 1 to million of interconnected pages, has hyperlinks to connect and help to find your way around the website. You can find different kinds of information on the web like games, health matters, holiday destination, train timetables, weather forecast and many more. There are millions of websites available on the internet and you can find anything that you are interested in. Each website has its own unique address which is called URL or Uniform Resource Locator. To visit a site, you need to type its address in the address bar of your web browser. The internet is used mainly for communication, to gather information, education, entertainment, current affairs, online learning, commerce, publishing, etc. In the uses of internet, publishing is not just used for organization or businesses. Anyone can create their own websites and publish their information or files on the World Wide Web. Through the internet, thousands of people around the world are able to access information for their homes, schools, internet cafes, and workplaces. We can send electronic mails or email to family members and friends with accounts on the internet, which is similar to sending letters by post. The email can be sent within minutes no matter where they are without postal stamps. We can post information that can be accessed by others and can update it frequently. We can access multimedia information that includes video, audio, and images. We can learn through web-based trainings and distance learning on the internet. Now we will discuss about the features of internet. The first feature is geographic sharing. The geographic sharing of the internet continues to spread around the world and even beyond. A main feature of the internet is that once you have connected to any part of it, you can communicate with all of it. The second feature is architecture. The architecture of internet is most ever communication network design. The failure of individual computers or networks will not affect its overall reliability. The information will not change or destroy over time or while transferring in between sites. And the third feature is universal access. It is easy to access and make the information like text, audio, video, and also accessible to a worldwide people at a very low price. Now we'll discuss about the benefits of internet. There are many advantages of internet, like the internet is loaded with data and information in a range of formats. The search engines that are available online are fast and powerful. The internet is easy to use. Students can become researchers due to easy access to data. Students are motivated to share their work online with the world. The internet appeals to different learning styles. Unlike paper, the web can present dynamic data sources which changes over time. The characters in an email don't get transposed or mixed up when they are sent over long distances. A student can access libraries around the world. In the current lecture, we have discussed about the history and evolution of internet. We have also discussed about the internet infrastructure and IP addresses. We have also discussed about internet and World Wide Web. In the next lecture, we will discuss about cybersecurity. Thank you.